This is the 310 to 311 review. Number 9, calculators are allowed. We have a man who's 6 feet tall walking at a rate of 5 feet per second toward a street light that is 18 feet above the ground. The question is, at what rate is the length of his shadow changing when he's 12 feet from the base of the light? So we're going to set up a picture in step 1, which is a street lamp. And then we have a man who is walking toward that street lamp. And as he walks, he's going to generate a shadow. So we're interested in the rate at which his shadow's length is changing. So I'm going to put a variable for that shadow's length. We also are told how quickly he is walking. So the distance that is changing at the rate at which he's walking is the distance between him and the lamp. So this distance we will label as x, and we'll put an arrow on it to indicate how he's walking, and we know dx dt. Now, one of the big errors that people make is they see that dx dt is 5 feet per second, and they neglect to pay attention to the fact that x is getting smaller as time goes on. So that means the rate dx dt is actually a negative number. So we also have on this picture some things that are not changing. The street light is 18 feet above the ground, and the height of the man is always 6. So now that we have this picture drawn, our goal is to relate x to y without introducing any additional variables. Looking at the picture, we can see that we have similar triangles. The little triangle is similar to the big triangle. So the relationships that we can write down from our similarity proportionality from geometry class would be that 6 is to 18, just like the short, small triangle's base is to the big triangle's base. So now we're in a position where we could differentiate right now because we have the relationship, so we could move straight ahead to step 3. However, we'll make fewer errors if we simplify this first. So I would tend to rewrite this as 6 times x plus y equals 18 times y. Then I'd distribute 6x plus 6y equals 18y. I'd combine my like terms. And I'd even divide off that 6 because it doesn't introduce any fractions. So now when I take the derivative of this with respect to time, it's going to give me a pretty nice relationship that's easy to work with. So I will get dx dt equals 2 times dy dt. So with step 4, we're interested in the instantaneous information, which is he's 12 feet from the base of the light. So I can go back to this picture and label 12. I could, if I needed to, exploit this relationship or even this relationship to figure out that y is going to be half of that, or 6. And then I can go to step 5, which is to replace in here everything that I know. I know dx dt is negative 5, and I'm interested in dy dt. So for step 6, I simply isolate dy dt. I get negative 5 halves, or negative 2.5 feet per second. So what this means in the context of the story problem is that at the instant in question, or when the man is 12 feet from the base of the light, his shadow is decreasing at a rate of negative 2.5 feet per second. Again, this will be multiple choice, so you will not have to write out the interpretation, but you'll need to be aware of what it is for all the free response problems.